Fantastic. So yeah, we should have a recording of this for everyone here. I think yeah, a good place to start is right on the screen here, and go into a clearer definition of state and action and policy, some points that have continued to come up as questions that people have. So yeah, in this case, for the challenge of learning these malaria policies, we've tried to make it as accessible as possible to people of several machine learning backgrounds. And in this case, the state is just not so as interesting as perhaps or as rich as it could be for the problem, and we could expose more state information. But in this case, the state for this version of the challenge and the problem describes each year that a decision is being made, and there's obviously a state transition between each of the years, with a notion that what is being decided is simply the action that should be taken in each of these states, which will proceed in an ordered transition. So there are 5 states describing years 1, 2, 3, 4, and 5, and these have a sequential transition through them. But should you look at the sequential decision-making task, what's being learned is which action should be taken at each state or year in the policy, which brings us nicely to what an action is. So in the framing of the challenge, an action is essentially 2 values between 0 and 1, and these actions describe the coverage in a simulated human population of 2 malaria interventions. In this case, bed nets, you'll see AITN, and spraying AIRS. And a combination of these 2 interventions defines an action at each state. Now, the question of what does a policy look like arises, whereby a policy is a sequence of actions taken across the states. So I will proceed on this to define specifically how policies are created and described for the challenge. What's being shown is just currently both the reward framing at each state and action. In this case, you'll see that practically what is being returned is an episodic reward. So this is a stochastic reward for the entire policy over the entire episode. You'll actually see later on that rewards can be observed in each state for the purposes of the sequential learning problem. But to ground it in the real application, what is really being observed is a final stochastic reward, which defines the health outcomes per unit cost of the interventions implemented in a policy. So we'll show how these rewards can be observed both from a policy and from sequential actions taken through across the states. So as we move down to the policy definition, like I'm saying, there's a policy pie for this challenge consisting of a temporal sequence of actions defined in code as a dictionary. So in this case, we have 2 interventions deployed in year 1 and no subsequent interventions. So this definition takes the dictionary with keys of each state through time and defines how much of each intervention the action is performed in that state. And this gives it, like I said, a definition whereby we're doing performing an action in the first year and nothing in subsequent years. And you can see how that policy is constructed and could be appended to a list of policies which could contain multiple policies to be executed and run. You can just, we don't need to step through that part, so you can just run all the required code. We'll obscure that and scroll down. Brilliant. Okay, so I'm keeping an eye on the chat as I talk through this in case any clarification is needed there. I'm very aware your microphones, I think, are off until some of us somehow activates them, if they can be. So please actively use the chat. We're not trying to silence anyone, just make sure you pose the questions there, and I'll try and address them as I'm moving through. We have this notion of a policy for the challenge, which defines these actions taken across the 5 states, which are the 5 years in which interventions may be deployed for this simulated environment. So this is a sequence of actions, and what we're saying is we can evaluate a single policy in one lever pool in the multi-armed bandit framing if we choose to do so. And in this case, I just wanted to hopefully ground us in what you may have run already from the challenge environment. And what we've done is extracted from the dictionary this list of 2 values which define the action in year 1, initialized the challenge environment, and evaluated the reward from that challenge environment of this single action. And as we can see here, we've got 0.55 coverage of bed nets and 0.7 spraying, evaluated once, with a total number of 1,000 evaluations remaining on this initialized environment, and receive the reward associated with that. Now, just to be very clear at the moment, there's now a step here. So the environment you've had access to so far was far better framed for performing these multi-armed bandit actions, with the full intention that people can use sequential learning also on the problem. And I just want to point out the distinction here that we're now initializing the challenge sequential decision environments as opposed to what's been run before. And this sequential decision environment allows the entire policy dictionary that we just defined earlier to be run in essentially, again, one lever pool of the bandit problem. So in this case, we are now establishing a reward by posting the entire policy of an action in year 1 and 0 actions in the subsequent years, and receiving a stochastic reward from that. And now, on that point of stochasticity, just the tutorial proceeds to kind of really give a sense of what that means for you. So we can place this reward in a list that we've just evaluated a single policy, and continue to repeatedly evaluate the same policy, building up a list of the associated rewards. And I think there should be, after these runs, a box plot that just describes that. Yeah, for the sake of highlighting the returns on that, and maybe it will come up, but I guess that's an additional visual description to the outputs that we have here. So this is purely a single policy that has been repeatedly run on the environment, and we can observe that we have a expected reward from that policy, as shown in the box plot, and some uncertainty around that, which is effectively described here. So perhaps this is really what needs to be observed as a slight update, is this way the policy is being defined, in addition to just being a list of two interventions to create the action. We have this dictionary defining at each state what action is being performed, and we'll continue to use this framing and structure for the sequential decision environment. So if we evaluate policies as a sequence of actions now, we may choose, instead of just doing single submissions of policies, to make observations after a single action, and have some agent that's making decisions on which action to make given its state as it proceeds through the simulation. So we're just going to do one episode with no intelligence here, a abstraction of effectively random actions based on some reward that's being measured through these sine and cosine functions. What you can see here is how the sequential decision-making environment is being reset for each episode. We're defining an episodic reward because that's equivalent to the rewards being observed for the entire policy, and then posting actions through the states of the policy. So as you can see in the output of that. Did you want to make a point, Sekou? Sorry.
Yeah, I'm just quickly correcting a variable name here.
Okay.
Episode reward.
Okay. Thanks. Brilliant. So yeah, as you can see here, we initialize an action of 0 bed nets and 1 spraying. And one thing to note is we're still using the same environment we initialized to run the bandit simulations that we had before to generate that box plot. So each environment initialization has a finite number of evaluations to it. As you can see, we've got 940 evaluations remaining here for this action, and that will proceed to actually reduce in a way for each action. So maybe, I'm not sure if it was explicitly generated in the above examples, but you'll see each action here counts as an evaluation. So evaluating an entire policy would be 5 evaluations from the environment. So as we go through the sequential actions, we can see an episodic reward is, well, we're keeping track of that ourselves as a summation of the rewards taken at each state by performing an action which should be intelligently chosen through your own code. Perhaps I can pause at this stage because 2 concepts have been introduced. Perhaps the first was a bit more familiar to those that have looked through the examples, and the second, this is new newer content, albeit framed in a way which those with experience will see a lot of similar content in terms of sequential decision making, and how actions, observations, and rewards are being taken from the environment. I'm just gonna see if any questions arise at this point, or perhaps I can proceed. Seiko, you've not seen anyone perhaps raising their hand or anything while I've been talking.
Since I'm sharing my screen, I don't have that view.
Okay, great. So let me, at this stage, proceed on to perhaps another point that we just want to be clear for the challenge and provide some additional information so that it's obvious how submission files should be generated, both to submit scores to the public leaderboard and also subsequently how we expect submissions to be encapsulated for evaluation as well when we run them. So this is again content extended from the getting started on the platform. Just in this case, I wanted to tie it together with how we've been evaluating policies in their entirety. So what should be noted here is, and as we provide instructions to as well, this is a custom agent class that should encapsulate your code really where updates or changes are made are in the generate method. Outside of that, we don't expect the values to be changed, and those can be explicitly set within both certain parameters that are constraints on the challenge itself. So, for example, you see an episode number in initializing the environment, and a particular number of runs being performed by the scoring function, and these should be common across submissions. But in this case, within the generate method, unfortunately, we're not giving too much away in terms of anything high performing for the challenge itself. But here, what you can see is essentially a random policy is being generated across the 5 years and evaluated for 20 episodes. So here the potential candidates of 20 different episodes of random policies are being posted to the environment, and we're using this evaluate policy method to return the rewards for those policies themselves. And returning to this idea that the policy is this list of dictionaries in the case of the candidates that is being handled by the API. And we're then looking across these 20 episodes for the best performing candidate. Now, this is entirely, again, unintelligent in the sense of the posting of the random policies and simply evaluating a single maxima in those evaluations from the stochastic rewards and returning both that reward and that policy, which is then being submitted into both the scoring function and returned in the submission file. So as you can see here with Seiko's pointer, the final, essentially the best performing policy and reward from those 20 episodes that are requested within 10 runs So each run consisting of 20 episodes, and 10 runs of 20 episodes will generate 10 results of the best policy that your implementation is returning, and the associated reward with that would be appended to that particular policy and scored. So again, we provide a method for generating the submission file as a CSV and create submissions which precisely lay out the outputs of what's being done here, and the call to do this can be seen in the lines below. Perhaps if we just run, I know nothing too interesting is going to be generated, but again you can see the environment is this challenge sequential decision environment. We're initializing, passing it to our custom agent code, running the scoring function to generate the policies and rewards across the runs to create our submission file. Now this is in total using the 1,000 evaluations permissible for each initialization of an environment. So you could see this as a constraint in the challenge, that for finding these highly performing policies, you have a total number of evaluations that can be performed by your code, and those are explicitly set out within these 10 runs of 20 episodes, each episode obviously performing 5 actions due to the framing of the problem and the policy, giving the total 1,000 evaluations, which is necessarily very constrained, as what we're perhaps obscuring for you for challenge participants is the amount of compute and resource that's gone into generating the data being queried here. We wanted to simulate the same conditions that go into generating that data in terms of the efficiency of the learning, to both very quickly, very efficiently explore and determine determine high-performing solutions to the problem as posed here, whereby what is the necessarily optimal policy in simulation as a combination of interventions of bed nets and spraying across a 5-year time period to be deployed from, like I say, a simulated model. I know we have another list of questions and points to address here, and I keep looking to see if there are any questions in the chat, but like I say, please send anything across in the chat window, whether if you want privately or obviously through the forum later, we can also address those. But if you feel like there's anything that should be shared right now, that would be very helpful. I think I just want to take a few seconds for Sekou while I've been chatting. I know there are points that I will have missed while running through that. Perhaps you want to raise them and we can go through them.
Right. So there are a couple. So yes, what's present right now is an addition to what you had before. So for the past 2 weeks in this feedback phase, I think about 50 people have actually tried downloading, running, and we've gotten some really good questions, key questions. And we also, in the next phase, will talk about the process. So the feedback phase, the test phase, etc. But we'll get to that. One thing I'd like to make sure that you know, you don't have to use an IPython notebook or a Jupyter notebook. You can generate this content using just a straight Python file or a set of Python files. There are dependencies, and each of those dependencies would have to be installed. So, for example, and these are standard Python, I would say, data science dependencies. So we're not asking any exotic modules to be installed. What I should also say is, if you do install things, the intention is that your submission, your ultimate submission, should be self-contained. So if there is any code that is not, like you can't pip install NumPy, for example, if you can't get as a dependency of a standard Python install with NumPy, scikit-learn, requests, etc., that code should be included in your submission. So in our initial phase, the submission is just a CSV. But once we get to actually verifying your code, this is what we'd have to do in the subsequent phases. We need to be able to run your code, and your code needs to run standalone. So just keep that in mind. Everything will be running in a completely offline virtual machine environment, and the base URLs that we're using will all be local. So just keep that in mind as you prepare your submissions.
So I guess
right. So the question is the scoring function fixed to 10, and yes, your code is evaluated 10 times. Yes.
I think
so that,
another point of clarification we wanted to raise in the Q&A is based on this 2-week feedback phase and what we've been observing from the leaderboard. So you saw this transition between what was being used and this sequential decision-making environment. All solutions which were developed previously will continue to run on the new environment and would return the same results. We want to make this transition clear, so you could continue to simply, when we post today the updated environment, run your code on that, though you would find it will be lower performing than generating a policy in both with actions across all of the years. And to that end, we will be appropriately updating the leaderboard with the new environment, though we believe it may update itself. Just wanted to be transparent that solutions will continue to run on the new environment and return the same results. But the update, we would highly recommend that both running your current code on it, you look a bit closer, both at the material we've presented now, and look to update your submission. And then I think other updates we have more generally for the competition, which haven't been directly publicized, are the awards for placing within the competition, and I think you'll see updates for those coming.
Right, so it's partially been updated, so it's basically just a blanket total number in terms of the total awards, graciously provided by KDD. But this will be updated to actually break down first, second through 10th. So the top 10 would get awards. And there will be conditions under which the awards will be able to be dispersed by KDD. All right, so but all of that information would be added to the description tab of the competition page.
And I think with that longer term view in mind, just making clear the timelines on the event from this feedback phase, making sure everyone's aware that in order to proceed, you'd need a top 100 placing on the public leaderboard. I think this is to really separate kind of motivated participants to then enter the submission phase. But I think there were some concerns raised around evaluation and validation of submissions on the public leaderboard. So we just wanted to ensure people that we're randomly checking even currently on the public leaderboard to ensure there's valid submission files that are not being constructed, and we really encourage no one to look for subversion of the submission process, whereby anything suspicious in the first case would simply be disqualified and reset to 0 as a score. If we saw a particular user repeatedly doing this, obviously we'd be in contact first just to check that it's not unintentional, but some solution that may be arising due to the problem not being completely formed. Though I think we've been through the iterative process on that, and if we could identify someone as trying to subvert the process, they would be disqualified from the challenge. So I think the point was just to confirm that we would like motivated participants to make sure they're posting within the top 100. Don't worry, we're doing diligence on ensuring that no one is trying to subvert the process for getting in that top 100. But even after if you proceed through there, you'll have to go. Everyone's submission will be fully evaluated on another new simulation and model, whereby we as the organizers will be running your code, and at this stage become very clear if files had been constructed in a way to somehow game the system rather from legitimate submissions.
All right, so just as a reminder, this recording is going to be posted, so if there are any other questions, you can feel free to ask those questions subsequently. But you could still take the opportunity to ask a question now.
So we just had a question from Chen that currently submissions were able to go outside of the 0-1 range on the previous environment. So that's, I think, and Seiko and I have been looking at this, and we all look to reset those scores which may have been generated from policies outside of the 0-1 environment, whether that's communicating a reset of the leaderboard so everyone can just repost their submissions to repopulate the leaderboard, or on an individual basis. So that will be addressed.
And just also sharing with you, Chen, on the back end, policies outside the range will not be, they will be capped or clipped. So even if it were possible as of last week, even if it were possible to get a policy outside of the legal range, it will not provide a response outside of the range. But we have changed both on the front end in terms of the API code that you are downloading, as well as on the back end. So there are two ways that it's being addressed. No problem.
I think more generally, though, we've been very impressed by participation on the forum and look to continue answering your questions there in a manner that perhaps is more targeted now to the updates. There were some points that we couldn't address directly as we were pushing these updates in the Q&A now, and didn't want to cause any confusion before this consolidated update. But really appreciate people's contribution in the forum and also sharing of what they're learning, and more generally us sharing more tutorials and code moving forward, as well as people giving a notion of what they think may be performing well in the sense of between the forum and perhaps sharing ideas. I think we acknowledge that this in itself is a challenge that has awards, and we look very much forward to meeting those people who submit solutions that tend to do well on the platform at the conference, and awarding those people. But also, I would like to acknowledge the framing of this problem is something that we're actively trying to tackle, and is a question where we really appreciate people giving insight into what they're learning from the code and learning from each other, with a slightly higher level goal that we're looking to generate solutions that could be deployed in real systems on the sorts of models that we've abstracted for you to run here, and look to solve the problem of malaria control and elimination.
So there's another question. This, in the submission file, they did not use all of the 10 episodes. So basically, they didn't evaluate 10 times, but there was no error.
So they shouldn't have to. 10 is simply a ceiling on the numbers of evaluations. If you choose to evaluate fewer, you will still be returned a score.
So if they don't do 10, what can happen negatively? Or if they do 10, what can happen positively?
So you could, as you can see in the scoring function, you can observe lower, potentially lower variation with fewer samples, though this would be slightly counterintuitive. But simply fewer evaluations may not allow you to post such a highly performing solution. I would encourage people to make use of the full number of runs available to them in what they're generating, but there should be no error should you run less than 10 runs. Unfortunately, in the current framing of the challenge, we don't reward you for using fewer. I think you'll find the 10 is quite restrictive in itself. Yeah, so there's no reward for running fewer. It's potentially, I would advise it's a penalty to anyone submitting a solution not to use the full number of evaluations. In terms of the detail of the restriction, each of the evaluations you run could be anywhere of 2 hours to 2 days of CPU time, as we try to simulate the real-world progression of this disease through the policy being defined, and what are the future outcomes, predicted outcomes, the models we're using. So the reason for the restriction is purely to try to capture the notion that every action that you perform has expense associated with it and compute time. Now, this restriction to a total number of 1,000 for the submission is very realistic in terms of what we're able to run on our own infrastructures and using these models. I know that's not very low-level description of the restriction, but a more high-level kind of conceptual understanding of why we're restricting it.
So there's a follow-up question. If you're just running 2 experiments, the score is higher than 10. So they're asking, if I'm reading this right, just really asking it to get more explanation on what it means to have an experiment number and a policy. I think these are just asking what's in the submission file.
Yeah. Do you have your interpretation of that, and maybe I can add to that second.
Okay. Hold on. I'm pulling up the rules that he's.
Also, is if you're running anything live right now, it would be on the challenge environment rather than the challenge sequential decision environment. Not that this should perhaps change what you're observing, but it could be that stochasticity in 2 experiments leads to a higher score than 10 simply because of the variation there. But I agree that in the evaluation page, we'll clearly spell out that there are 1,000 total evaluations done in the submission process to generate the scores and the file which you're posting to the leaderboard. And the bounds on the policy of 5 years will also be spelled out there. You will find in the updated API, should you try to do anything outside of that, you will receive NaN rewards. Just trying to run through different channels to check.
Okay, so one of the other things that will be coming via the forum as well is that we'll be setting up office hours so that we can actually, in the times between these Q&A sessions, we can actually, there's a time that you know that we should be online. We're across a couple of different time zones, and we know you are as well. So there will also be a poll to see what might be a good time, but we can't promise that we'll be available exactly when you're available, but we'll do our best. And we've asked a couple of friendly faces in other time zones to help us out in terms of just making sure that the questions that you have as challenge participants can be addressed in the shortest time as possible.
And I think once we establish a time that perhaps in this multi-objective optimization may work for everyone, we also would like to move on to some more exciting content in terms of introducing things that are, just using RL in a much more interested and implemented fashion on the challenge environment, and sharing some of what we've been successful with, and we can maybe give a chance to for some of the participants, if they wish to, share some of their progress as well in those courses. Are there any more questions on the Q&A? Brilliant. So I know at this point we want to take the opportunity for the KDD Cup chairs also to give some background on the challenge, and I think Seiko is trying to beam them in onto the audio or the host, so you still have time to ask questions as he looks at making that possible. I think Taposh, I think I've been able to unmute you. Maybe if you...
Sure.
Yeah.
No. So I want to take this opportunity to thank both Seiko, Oliver, Ankur, Uday, and the entire team, KDD Cup team, Irina mentioned as well, to put together this competition. Doing RL competition for the first time was huge for KDD, and it's huge for us to learn and share. So thanks a lot for organizing the competition and also for organizing this Q&A session. And I think this will help. This video will help other people as well in the future. And KDD chairs are also thinking of organizing more sessions with basics of RL as well for people who want to more participate in the competition. So thank you Oliver, thank you Seiko. I really appreciate it.
No problem. Thank you.
Okay, and yeah, I guess thank you for all participants as well on the call. And yeah, I just wanted to reiterate thank you to the team at Hexagon-ML on the platform, and really supporting also your questions in the forum and tirelessly working on this as well. You've not heard from them today, but perhaps we can have an opportunity for them to speak at some point.
All right. Well, I guess if there are no further pending questions, we can pause at this moment and continue live on the discussion forum. And thank you all for your time.
Thank you.